Ever wondered why statisticians don't survey every single person in a study? Keep the content coming by hitting subscribe. You won't regret it. What's the difference between a population and a sample in statistics? Well, let's unravel this mystery. In the realm of statistics, population and sample are two fundamental terms that we encounter frequently. The population refers to the entire group that you're interested in, the group about whom you want to draw conclusions. It's the total set. For example, if you're interested in knowing about the reading habits of high school students in your country, then all high school students in your country make up your population. On the other hand, the sample is a smaller specific group selected from this population. It's a subset of the population that you actually examine or survey to gather data. So if you're studying the average height of adults in the United States, the population would be all adults in the United States, and the sample could be adults in a particular city or state. Now that we've defined the terms, let's compare them side by side. When we think about gathering data, the ideal scenario would be to collect information from every single individual within our area of interest. This is what we call population data. Imagine trying to figure out the average height of all adults in the United States. To get that information using population data, we'd need to measure the height of every single adult in the country. That's over 200 million people. As you can guess, this approach is often impractical or downright impossible due to constraints such as time, resources, and accessibility. This is where sample data comes into play. Instead of trying to measure everyone, we take a smaller group that represents the larger population. This group is our sample. If chosen correctly, our sample can give us a pretty good estimate of the population. Let's consider a real-world example: political polls. These polls don't ask every eligible voter their preferred candidate. Instead, they ask a sample of voters and use their responses to predict the election outcome. The key here is to ensure that the sample is representative of the entire voting population. This means including people of different ages, socioeconomic backgrounds, and geographical locations. Another example is in the field of medical research. Suppose scientists are investigating the effects of a new treatment. It's not feasible to test this treatment on every single person who has the condition they're studying. Instead, they select a sample of patients, administer the treatment, and monitor the results. The findings from this sample can then be extrapolated to predict how the treatment might affect the larger population of individuals with the condition. In essence, a sample is a manageable, practical way to gain insights about a larger population. It's a snapshot, a small piece of the puzzle that, when selected with care, can help us understand the bigger picture. It's not perfect, but with careful planning and execution, it can provide us with valuable, actionable information. So, let's recap what we've learned about populations and samples in statistics. It may sound like a mouthful, but these terms are actually pretty straightforward. In the world of statistics, a population isn't a group of people in a country or city. Rather, it's the entire group you're interested in studying or drawing conclusions about. It could be all the apples in an orchard, every student in a school, or each star in a galaxy. On the other hand, a sample is a slice or subset of that population. It's like taking a handful of apples from that orchard, picking out a few students from that school, or observing a few stars in that galaxy. When we say sample, we're talking about a manageable, representative group that we can actually study. Now, you may be asking, why can't we just study the whole population? That's a great question. In an ideal world, we would. But in reality, it's often impossible to collect data from an entire population. Imagine trying to weigh every apple in an orchard, or measure the brightness of every star in a galaxy. It's simply not feasible. So, we turn to samples. A well-chosen sample can provide valuable insights about the population. We can weigh a few apples, and use that data to make an informed guess about the weight of all the apples in the orchard. We can measure the brightness of a few stars and use that information to infer something about the brightness of all the stars in the galaxy. But remember, the key here is well chosen. A sample must be representative of the population. If we only picked the smallest apples or the dimmest stars, our conclusions would be skewed. So choosing a good sample is vital. Remember, the beauty of statistics is that it allows us to make informed conclusions about a large group based on the study of a smaller, manageable group. That's the magic of population and sample and statistics. Subscribe to keep the fun going. More content awaits.